Thank you so much, Jason, for the introduction. And hello, everyone. And thank you for joining us today for this session about ingestion time transformations in Microsoft Sentinel. We have a packed agenda for today. Javier will take us through an overview about the feature that was released recently to public preview. We're going to speak about DCR-based custom logs and what is actually custom logs v2. In addition to that, we prepared for you a set of demos based on scenarios we've been seeing and being asked by our customers. And we'll wrap up with the feature benefits, advantages, and the support provided across Microsoft Sentinel for the various ingestion options. We'll equip you at the end with information and resources to continue exploring this exciting feature. So without further ado, Javier, how about taking us through the overview of the feature?
Of course. Thank you, Eddie, and hello, everyone. So yeah, let's go for it. So first of all, we're going to be talking about two main features that are currently in public preview. The first one, it's called Ingestion-Time transformations for standard tables. We'll be drilling into that in a second. And the second one is the data collection rule-based ingestion for custom logs. It's a new version of the custom log ingestion that we used to have previously in Log Analytics. If you remember, it was called the Data Collector API. Now we have this new version. So in conjunction, these two features really provide a new set of capabilities that will really make a difference into a customer environment. So let's take a look at all the different use cases that these two features will allow in the short term. First of all, the first one is ensuring a standard data format. So as you know, in Sentinel, we ingest a lot of different data formats, different data from different data sources, and we want to make sure that it's easy for customers to parse that data and to normalize that data, making sure that we can extract the valuable information from those logs to really empower our SOC to take the best decisions. This really connects a lot with ASIM, the Advanced Security Information Model. You probably have seen webinars before from our friend Offer in this topic, and it's really very much connected with this. We also have a different set of capabilities, which is remove irrelevant data, duplicate data, and also the ability to mask or obfuscate sensitive data. First of all, filtering. Of course, there's data that maybe our SOC doesn't need, that really doesn't add any value to our security operations. So we want to be able to just discard that data if it doesn't add any value, so we can optimize our costs. Also, as we mentioned, obfuscation and masking. There might be PII data that gets into the different logs that we ingest into Sentinel, and we might not want our SOC team to really visualize that PII data that is in those logs, so we now have the ability to obfuscate it. An additional use case is aggregation. So there might be specific data sources, like, for example, proxies or firewalls that are repeating the same message again and again, right? We want to basically aggregate that data as much as possible, still have the context of what was the specific message that happened, but without those duplications. That can also be accomplished with this ingestion transformation, but supported by third-party tools, like, for example, Logstash. And we'll touch on this as well later. And the last use case that we wanted to mention is the enrichment of data, being able to basically add additional context to the different records that arrive into our Sentinel workspace.
So Javier, just before you deep dive into how ingestion time transformation looks like also under the hood, can you review what we have currently from ingestion perspective and how it changed, and also what was the motivation to do this change?
Absolutely. Great idea, Eddie. Let's take a look at how the Sentinel data flow worked before the ingestion transformation was here. So on the left, you see the different Microsoft Sentinel data connectors. You see here now two categories. We'll show more in a second. But you have the service-to-service connections. These are the typical connectors that we use, for example, for Office 365. We use it maybe for Azure Active Directory, and so on and so forth. And we also have the two agents that we currently support. Azure Monitor Agent, the new agent that you might be familiar with, and also the Microsoft Monitoring Agent, the legacy MMA agent. So for those different data connectors, we had a log analytic process that we called standard logs, and that used what we call hard-coded workflows, This means that Log Analytics engine was responsible to make sure that the different data fields were in the proper format, they had the right shape, and they actually complied with the schema that we defined in our standard table. So the data at the end, in this flow that was coming from service-to-service connections and from our agents, it landed into the standard tables in Sentinel. We also have our API-based connectors, when we basically push data into Sentinel via the Log Analytics Data Collector API. This, again, is called the custom log processes. And what we had in that case with the Data Collector API or custom logs V1 version 1, we had automatic parsing. So the Log Analytics engine was responsible to actually assign a type for each of the different fields that were pushed into the Sentinel workspace. And the data was ingested always into our custom tables. If you remember, all those custom tables in Log Analytics have the _CL suffix at the end of them, right? So this is how the different workflows work in Log Analytics. Let's take a look at how this changed with the addition of the ingestion-time transformation features. So we still have on the left the same service-to-service connections, and now we have grouped into a single bundle MMA and AMA. They still go to the same workflow, standard logs, and the hard-coded workflows, but now we have added the option to do ingestion-time transformations, to massage, to reshape the data as it is getting ingested into the workspace, and it lands into the standard tables. Additionally, with this feature, we are able to extend the existing schemas that Microsoft have defined with the addition of new fields. So if, for example, I want to extend the sign-in logs table schema, I can now add a new additional field that will have an _CF at the end for custom field at the end of that table. So we can have an enriched set of capabilities with the same table. The API-based connectors that we saw before that use the old data collector API still use the same kind of workflow, but now we call them DCR-based custom log API. So it's a new API that is used for these logs, and it also comes with new capabilities. First of all, I can define the table schema. So that is not automatically parsed or determined by the Log Analytics engine. I can now explicitly tell Log Analytics which specific fields I want and what is the type that each of them will have. Not only that, I also have now the option not only to ingest into custom tables, but also to ingest into the standard tables that we were mentioning before. And we will see later what are the limitations. There's a limited set of tables that are supported in this scenario, but it opens up that option that was not available before.
So Javier, quick question. And
yes,
you move now to data collection rules, but indeed DCR, of course, stands for data collection rules. And we see it appear here as a major part of ingestion-time transformation. Really good opportunity to review what's a data collection rule, how do we use it, what kind of types do we have?
Perfect, let's do it. So first of all, what is a data collection rule? Basically, it determines the data flow of the different input stream. What does this mean? Really, it means that you can declare how you want the data to go into the service, into Log Analytics, and then we can determine where it goes, right? Into which specific table it goes into, what workspace it goes into. So that's basically what a data collection rule defines. That being said, we have two different types of data collection rules, okay? The first one is called a standard DCR, standard data collection rule. If you have been using AMA for the last few months since it was available, that's the type of DCR that is used in AMA. Okay, so again, data collection rule that you use in AMA, this is what we call the standard DCR. And now it's not only used by AMA, but also by the new custom log version 2 or the new custom log workflows that we were talking about. Okay, that workflow that allows you to ingest, for example, into standard tables. Okay. The second type of DCR is called workspace transform DCR. It's a special kind of DCR for workflows that do not support the standard DCR. So basically, those other tables that we have in the workspace, like for example, sign-in logs, like for example, office activity, and many others. So all those tables that do not come into the workspace via AMA or via custom logs, for those we use this workspace transform DCR. Important, that DCR is only one per workspace. But that doesn't mean that I cannot apply a transformation for many tables. I can still contain within that same workspace transform DCR, I can contain separate transformations for each of the different tables that are there, okay? Still, not all the tables are supported. It's a very wide list of the subset of tables that are supported, and we'll provide the details at the end of the presentation with some links on which ones are supported, which ones are not. And most importantly, the specific thing that makes the CCR capable of doing this ingestion-time transformation is KQL language. So basically, within these DCRs, we will be able to specify a transformation that is based on KQL. So basically, we will say, we will tell Log Analytics to massage the data, to reshape the data based on that KQL. So Eddie, we already reviewed a little bit these features at the high level. Can you tell us a little bit more about real-world scenarios on how this can be applied?
Can you see my screen? Just verifying I grabbed it and
yes,
everyone can see it.
We can
perfect,
see it.
Perfect. Thank you, Javier. So yeah, now that we know what ingestion-time transformations are, how they're built, let's see a few examples of real-life scenarios. The first one we'll start with is filtering, simply removing data and columns from events that we actually don't need for investigation. So basically, we're using, as Javier mentioned, a very simple KQL statement in this demo. We're starting with the keyword source, which might be not familiar to some of us. And this is mainly, and usually you would see here the table name, but we're speaking about ingestion-time transformation, and we're massaging the data, filtering it, masking it, as we'll see in the demos, before it's getting ingested, sorry. Hence, we're using the source keyword, and after that, simply using the project away statement and specify the columns that we want to filter out. It's important to mention, as you'll see in the demo, we define the data collection rule, we define the data collection KQL statement. As soon as it's being deployed, it affects the ingested data. That means if you have ingested logs before the data collection rule was applied, you will see basically the data that's before filtering and data after the filtering where the data collection rule took effect. Let's see it in a live demo where I simply move and start from the tables blade, which is a new blade in Log Analytics. So we, as we mentioned, it's a feature that we have in Log Analytics and Sentinel. And the tables pane is actually the place where we look for the tables that we want to define the data collection rule for. We're choosing here the AWS VPC flow table. So that's where the logs for AWS VPC flow are being ingested to, and we're creating a new collection rule. So I'm going to pause for a second here and just mention a couple of important things. First of all, you can specify, of course, the subscription, and the resource group is taken by default from that workspace, but you can create also a new resource group to have your data collection rules there if required. The region is not updatable because the data collection rule has to reside in the same region where your workspace resides. And of course, the name that you can provide to that data collection rule. As soon as we're done, we're moving to the next screen where we have the table preview and we have the transformation editor. So we're starting just by typing the source keyword, and then we would get the preview of the current table, AWS VPC flow, and then we're using the project away statement with the fields that and the columns, of course, that we want to filter out. So we can see that in the preview, when we run it, we will already see the data with empty fields for those columns. If we're happy with the result, we're going to apply, hit the next button, and create the data collection rule. As soon as we create it, it's being deployed. It's a new resource, can be reflected in JSON as well. And at this stage, we can move to Microsoft Sentinel and see the impact of that data collection rule that we just created. So we go to the logs to run a query on AWS VPC flow log table. And we're gonna order by time generated, because we want to see the difference between how the table looks like before and after the data collection rule was deployed. And we can see that when we sort descending, we get the version column and the instance ID column empty as we wanted. Moving to the next scenario, which is also about filtering, but now we want to filter upon values in certain columns. In that example, we want to filter all the actions in the VPC flow log table that do not contain the value reject, meaning we want to see only the reject actions, so to say, in the table. We're going to use the where statement. So this is the KQL transform statement. And you can see it's quite simple. We use where action, the column action contains the value reject. Let's move to the demo. We're starting in the same place in the tables blade in Log Analytics. We're running this demo against, again, the AWS VPC flow log table. We're creating a new data collection rule and moving to the transformation editor. As soon as we type in the where statement and hit the run button, we will get a preview of the table that will include only the rows with action reject. We hit the apply button, next, and we're ready to deploy the data collection rule. And then we can move ahead to Microsoft Sentinel and see the effect it has on the actual table that the SOC analysts and the SOC members would query for any purpose of investigation, hunting, and other activities they perform. So again, sorting by time generated and ensuring we get the right result. So first of all, we didn't sort descending, and then when we hit run and we saw descending, we see only those rows with the action reject value in them. We spoke about enrichment and tagging. So there's so much new features. There's so many new features that ingestion-time transformation provides, and one of them is adding custom fields to existing tables. So in this demo, we're going to add a custom table, a custom column, sorry, for the AWS VPC flow log table that we saw in the previous two demos. And here we're going to use it for indicating whether an IP that we're receiving is internal or external upon, just for the sake of the example, some logic that we invented. The main thing is to highlight why would we do it, for which purposes. So we can use it for translating a value into customers' business-related kind of value, whether it's GeoIP, department names, etc. We can also enrich the field, enrich the existing table with the field in the event with additional any meaningful information that can be, whether again, it can be this internal, external IP and any other information. What we see below, and we'll see it in the demo, is how we define and deploy this new custom field. So we need first to use a very simple JSON to describe this custom field. We'll specify the table name, we'll specify the name of the custom field, the description, the type, etc. And then we run a PowerShell method, which is in vogue AZ REST method, to run basically and invoke the API for adding this custom field with this simple JSON that describes the custom field. So let's see it in action. First of all, showing you how it looks like in PowerShell. So I have here a PowerShell window, and I'm first of all describing the custom field and then invoking the AZ REST method, invoking the API for creating the custom field for that table. If it runs successfully, it simply kind of dumps the table schema, and if we scroll up, we'll see that we have successfully added the custom field, right, with all the relevant properties. If we move forward, so just for the sake of the explanation, the logic behind it for the example is that if the first octet is greater than 100, it will be considered as internal IP, otherwise external IP. The KQL is quite simple. As we see, we extend the query result with the custom field, and we use a case statement to define this logic that you see above. If we go to the demo, it starts just like the other two demos, but here, although we'll use the same AWS VPC flow log table, we're going to edit the DCR. So we're using already the previous DCR, where we already have both filtering statements that we had and adding the case statement to enrich the table and the custom field value. We run the KQL query, we see the result. As you can see, the filtering works, the enrichment works, and we're happy with the result, and we move forward to apply and to create a data collection rule. And then if we move forward, we can already see the result in Sentinel while we query in Sentinel the AWS VPC flow table, and we see the actual result with the custom field and the filtering. So we took basically all three scenarios, built one data collection rule that holds all these three scenarios, for 2 for filtering and 1 for enrichment. So we spoke also about PII and masking, but I'll ask Javier, would you take us through this demo?
Perfect. Yes, thank you, Eddie. So hopefully you can see my screen now.
Yes.
Perfect, thanks. Cool, so yeah, let's take a look at PII masking and obfuscation. So first of all, why is this use case useful, right? And when can we use it? So it can be very useful in a specific context of having some fields in our log stream that contains PII data, right? Like for example, an SSN, a social security number, a credit card number, maybe an email address, or maybe a physical address. And we want to make sure that that kind of personal information is masked, so the different analysts and operators of the system cannot really look at that data. So here in this scenario, in this demo that I'm going to show you, we're going to have a specific table that is going to have two fields, an SSN field and an email field. And what we're going to try to do in the transformation is we're going to try to mask that SSN and replace the email with something else, with a text. So we basically hide that information from the end user. So we start, like always, with the source statement. This is the input stream that is coming into the service. And then the SSN, obviously, we expect something that is separated by a dash, right? So we use the split command in KQL to just make sure that we have different sets of parts of the SSN, the 3 parts of the SSN. And then we just apply a regex, right? We apply a regex that identifies when the SSN is a valid social security number. And if it is, as you can see over here, we replace the last 4 digits with YYYY. Okay. If for whatever reason the SSN is not valid, it doesn't really match the regular expression that we defined here, we'll just replace that field with an invalid SSN string. Okay. For email, we're going to do something similar. We basically check if the email field is matching this regular expression, the regular expression of an email address. If it does, we'll just replace that email address with this text, PII data removed. And then we'll leave the email if for whatever reason it doesn't match an email address. We at the end project away the intermediate field that we use, the parse SSN field that we use for the calculations. We don't need that anymore. And then we just project the ones that we really need, time generated, the SSN, and the email. By the way, all these different transformations that we're showing in these different real world scenarios, they're going to be in a library that we're going to share at the end of the presentation. So you'll have them available for you to use. So let's take a look at the demo. So we're here in Sentinel, as you can see, my workspace, and now I have created a new custom log table. We go to the custom log view, and we have a new customer data underscore CL table that has 2 new fields, email, SSN, that I'm going to use in my demo. I'm going to check if the table has any data right now. It's empty. And now I'm going to go to my Visual Studio Code where I have a PowerShell script that is pushing data to this table. As you can see, I have 2 records right here in this JSON object. I have these 2 records. The first one contains an SSN that is a valid SSN. And then I'm going to put an email that is also valid, like sparkdemo@contoso.com, for example. And then the second record has an invalid SSN. Those 3 zeros at the beginning make it invalid SSN. And then I'm going to write something that is not an email, like this is not an email, for example, right? It doesn't comply with the regular expression that we need. So we're going to send that data to the workspace, and let's see how the transformation has affected that data that I pushed into the workspace. I go back to Sentinel, I run the query. Hopefully the data is already there. It will take a second. There it is. So now I can check the two records, and as you can see, the one at the bottom, the SSN was removed. It says it's invalid SSN because it was not a valid one. And also it says that the email is not an email, so it's not removed. And then the first SSN is masked. And also we have removed the valid email address with the PII data removed text. So as you can see, we have effectively executed ingestion-time obfuscation and masking. Okay. We've been talking mostly about transformation, right? How to reshape the data when it is ingested. What about sending custom data into Sentinel using this new DCR-based custom log experience? So again, users can now use these standard DCRs to implement transformation whenever you're ingesting custom data. Okay, imagine that I have a set of new data that I want to push into my Sentinel workspace. I can also now transform that data at ingestion time. Data might be ingested to either a custom log table with this new capability or to a standard table. But in Microsoft Sentinel, the standard table should be one of these 5 that you see in the screen. Windows event for Windows events from Windows, security event for Windows security events, syslog from Linux, common security log, which is our Ceph specific table, and also our new normalized DNS table, which is called asym DNS activity log. Okay. New additional tables will be added in the future, but as of now, we support these 5 tables to actually get data through the API. And by the way, we have 2 main ways to push data through these DCR-based custom logs. One is API, as I said. As I did in the last demo, I was using PowerShell. You can use Python. You could use whatever programming language you think is best for your scenario. Or you can also use the Logstash plugin. So coming soon, we will have a new Logstash plugin that will actually support these new DCR-based custom logs. Let's take a look at a demo on how to create a new DCR-based custom log table. It's quite simple. We're starting in the same spot where we started the other demos at the tables section in Log Analytics. So we go there, and now we have a new dropdown that allows us to create a new custom log, and then it's DCR-based. We go there. We give it a name to the table. It's going to be an Apache Access table. That's going to be the name, underscore CL, obviously, as always. We're going to create a data collection rule. We're going to create a new one that is going to also be called Apache Access DCR. That's going to be the name of our data collection rule. And then we have to create one new component that we didn't talk about before, which is the data collection endpoint. This is basically a URL endpoint, which is the one that I use to push the data to. Okay, it's very simple to create, so we didn't have time to review, but in this case, I have it already created for you guys. And now we get to this screen where we have to actually upload a sample of the logs in JSON format. So we have to have that data before I can continue. So I'm going to go and grab a sample of the data in JSON format. And then it loads in the screen. It's telling me already a warning, telling me that, hey, you don't have any time-generated field, and that's required by Log Analytics to have that field. And also I see that I have this raw data field that looks very ugly, right? It's all the raw data without any way to make a meaningful, any meaning of that data, right? So let's go to the transformation editor and see how we can massage that data at Ingestion-Time. So first of all, we want to make sure that we add that time-generated field appropriately. So let's actually write that. We're going to extend that source stream with time-generated field. It's a new field. And that is going to come from transforming the time original field that came into the data and doing a today time function. So that way I have now a time-generated column, but still the raw data is looking pretty bad, right? So we have implemented here this a little bit more complicated function that already does all the parsing for you, right? It's all doing using the parse command in KQL. And as you can see, it parses everything properly. Now I have my client IP, my request type, my resource, response code. Again, just transformation and ingestion time like we did before. And then when we're happy, we just create our DCR that will allow ingestion of custom logs into that table. So that's how the experience looks like. Okay, we want to talk about also the new Logstash plugin that is coming soon. It's still in private preview, but it will be coming really soon and available into the product. So this new version supports this new type of custom logs, the DCR-based custom logs. It allows for performance improvements, and also it has some additional optimizations. Like, for example, we are allowing data compression in this new version. It can coexist with the custom log v1 plugin. So in the same Logstash pipeline configuration file, I can have both plugins. The old plugin maybe sending to a custom log table, and I can have the new plugin in the same pipeline file, just sending data to a standard table, for example, right? And also this new plugin allows for better error handling and new telemetry that is going to be sent into the service. So when is Logstash needed in this whole story, right? So basically, there's two main scenarios where Logstash can help. First of all, aggregation. We mentioned that use case at the very beginning of the presentation. That's still a valid use case where we need aggregation, and we're actually going to do a demo of that specific scenario. But also when we need enrichment with external data sources, right? Right now in your transformations, you can only reference things that are in the source stream, in the stream that is coming into Sentinel. You cannot reference something that is external to that context. So if you want to enrich with additional external sources, you can leverage Logstash. So let's take a look at a demo of this now. And we're going to demo this aggregation piece. So let me actually put the pointer here so it's easier to explain. So we have, first of all, a VM in the environment that has the Logstash component and the Logstash plugin installed. And it has, obviously, as any Linux VM, it has a barlog syslog file. And then I have a user that is going to try to log in. He's going to log in into the VM, and that is going to generate different messages into the syslog file. So those logs are going to go into the syslog file. Again, I'm going to try to generate some traffic, like generate additional sessions started messages. That's going to be, those messages are going to be processed by the Logstash plugin. And we're going to specifically use the aggregate function to take a look at all these started session logs or records and then aggregate them. So we're going to look at a 15-second interval. So during 15 seconds, we're going to be capturing all those messages. And we're going to make sure that instead of pushing all that data into Sentinel, which is repetitive and doesn't add any value, we're just going to have a single message that is going to say multiple logins message detected. And then we're going to populate a new custom field that we have created, created in our syslog table. And that's going to be sent into Sentinel via the Logstash plugin that we just talked about. And then it's going to be written into the table. So then we'll see a multiple logins message, and then the number of times that message was repeated in the logins_cf field. So let's take a look at this live in a demo. So we're here in the Sentinel workspace. And here we have our syslog table where we have actually created this new logins_cf custom field. We're going to take a look at that table. If I query, we'll see that we have all this data and we have the login CF currently empty. That field is currently empty. We're going to go into our VM and I'm going to generate 4 login events. I'm going to just create a new login. I'm going to open a new screen, duplicate the tab, do it again, twice, 3 logins, and I'm going to generate a total of 4 logins to this VM. So that will generate 4 messages, right? So this will take a little bit to actually do the aggregation in Logstash. So let's go and take a look at the Logstash file. This is my pipeline file where I have the input section that is coming just from syslog, from bits. Then we have the filter section, which is the most important part, where we have some grok filtering just to parse the message. And then we have the aggregation part, which is going to be executed whenever they have the start a session message. And then what we do is we increase the counter of logins by 1 every time we see this. We do it by 15-second intervals, as we talked about. And then we put this message, multiple logins message detected for user. And then in the output, we have the new plugin. And then we have all the necessary parameters for that plugin, like the client IP, secret, data collection endpoint that I talked about, and the data collection rule parameters. Then we're going to go into the workspace and see if this worked. And indeed, now we see this new message that says multiple logins message detected for user. And then we have 4 logins in that logins_cf field. So the aggregation was basically successful. Okay, so one of the questions is, hey, I'm already using custom logs v1, using the log analytics data collector API. So how do I migrate into this new version of custom logs? So there's basically 2 migration paths for those users. You can just create a new table, right? You might be able to configure a new DCR-based custom log data connector or just DCR that will ingest data to a new table. That can be either a custom log table or a standard. This approach may be preferred when you want to explicitly define the new schema, right? And eliminate the need for any query time parsing, right? So if you were ingesting the data into automatically with data collector API, maybe the fields didn't have the names that you wanted, or maybe the types were wrong and things like that. So if you want to explicitly define the new schema of the table, this is the option for you, right? And again, you can do all the parsing at ingestion time instead of having to rely on query time parsing. If you have already existing data, existing content, you can just leverage the existing table. You can configure a new DCR for custom logs that will ingest the data to the existing custom table that you were using before. This option may be preferred if you already have a lot of data in that table and you have already maybe developed a lot of custom content. Maybe you have detection rules on top of that. Maybe you have hunting queries. Maybe you have workbooks that are leveraging the data within that previous custom log table. So if that's the case, you can use this tutorial that I put here in the chat that basically just execute a call to an endpoint in log analytics, and that will migrate the existing custom log table into the new DCR-based custom log table. Okay. Cool. So Eddie, we already reviewed a lot of the different real-world scenarios. We talked about filtering, we talked about enrichment, we talked about obfuscation, etc. So can you tell us about what is the actual support of this feature for the different Microsoft Sentinel data connectors?
Sure, Javier, and great demos and a lot of information, of course, to absorb. Let's add to that, of course, the support. So we're in preview. We already said we're in preview. Some of the support is coming soon. And we wanted to share with you basically per connector type, what are the transformations that are supported and whether you can do it through UI or API configurations. So as you can see, the AMA standard logs and AMA custom logs are supported by these standard DCRs. For AMA custom logs, it's coming soon, and the support currently is only through API to configure it. For the rest of the connector types, MMA standard logs, MMA custom logs, the diagnostic settings connectors, And the service-to-service connectors, for example, the AWS S3 generic connectors, are supported by transformations for workspace transformation DCR, except of MMA custom log, which is an exception at this stage, and it's coming soon. However, the UI and API are supported for configuration, and you can do it whether through the UI or through the API. We did add kind of the small asterisk for the diagnostic setting connectors and the service-to-service connectors, saying that the support depends on the specific connectors tables. Everything is already documented and will equip you, of course, with all the documentation, so you'll have all this information with you. So we did an overview of the feature set, we saw the demos, and we want to start to wrap up. And we'll start with the advantages that we can highlight for ingestion-time transformation. So first of all, cost optimization. It's clear that if we filter out irrelevant data, we have an opportunity to optimize the costs. We also improve the analytics. So shaping out the output schema to accommodate your SOC analyst needs is also key for our customers. So we see that ingestion-time transformation can assist and improve this as well. The enrichment, of course, can save time for your SOC analyst to have more information as part of their investigation. And of course, allowing ingestion of more sensitive logs by either masking or filtering any PII or sensitive information within the events is also key for our customers. We're aiming also to improve performance, because when you reduce the need for query time adjustments, you end up with a better performance. And also when you remove irrelevant data, can increase the analyst efficiency. Except of the Logstash, which Javier presented, the ease of use here is also increasing because there's no need for any third-party tools to perform some of the actions that we saw in the demo, such as filtering, masking, etc. So with that, what resources do you have already available in the preview? So a lot of technical documentation is waiting for you out there, and we specify here the available documentation. Javier mentioned it in a bit, this new Sentinel transformation library that we created for you, so you won't start from scratch. And we have a lot of sample DCRs there for the scenarios you saw in the demos and more for filtering, masking, enrichments, and of course, Logstash is also coming soon as samples in this library as well. It's a GitHub library. And we mentioned it's a public preview. However, it requires a sign up. So a very short process to sign up in this aka.ms custom logs preview form. And then you can start enjoying the features that you saw here. I really hope that was valuable for you. Javier, thank you so much. It was a great pleasure to deliver this webinar together with you.
Same here, Eddie.
And really, thank you all for all of you that participated this webinar. We're going to stay a few more minutes for Q&A. Thank you so much. Over to you, Jason.
Great, thank you so much. We do have a few questions here. First one is it possible to track the modifications and changes that are made for DCRs?
Well, if you're using CI/CD, so if you host your different Azure resources in a source code repository, for sure, right? That's the whole idea of that approach. You will, for example, host your DCR definition, the data collection rule definition that will contain the transformation. You will host that into a source code repository, and then you will be able to track changes whenever someone makes a modification to that data collection rule.
Great, thank you. Next question. What permissions are required for creating DCR rules on a Sentinel workspace?
So I think you actually need a log analytics contributor role. if I'm not mistaken.
Yes, indeed. And it also appears in the documentation.
Okay. Next one. Is it possible to change data that is already within the workspace afterwards using DCR?
No,
No.
that's not the case. No, it only affects data that is being transformed at ingestion time. After the data is ingested into log analytics, it stays as it is.
Great. Next one. For CEF, what are the benefits of using log analytics tables versus changing the config file on the syslog server?
Good point. So first of all, you can do filtering at the server level. So just manipulating or just configuring our syslog or syslog-ng to do filtering at the agent level. That's perfectly valid. It's a great approach because actually you also save on bandwidth. So the data will be filtered coming directly from the host. If that for whatever reason is more complex for you, or you want to do a specific enrichment that is more related to log analytics in Sentinel, then it would be appropriate to do it directly using the workspace transform DCR that we mentioned in the webinar.
Great, thank you. Next one. Often I have problems with associating data across events. Will this custom column be addable manually as well? Let's say I want to associate user details with a specific event ID that does not map the user details.
Not sure I get the full context of the question. Yeah, so I guess that the simple answer is that within the transformation, you can grab any information that is in the event itself. Right. So imagine that, for example, you want to extract something from the event to put it in a new field, or you want to do an operation between different fields to generate a new field. Those kind of things you can do. If you need to reference data that is external to the context of that stream of data, that is not possible. You can assign static mappings within the data collection rule. That is possible, and we have some examples, I think, in our transformation library. So yeah, Eddie, I'm not sure if you want to add something else.
No, we saw a few. We saw in the demos that we can enrich with some logic in KQL. Fully agree that you can add also operations such as concatenating fields or extracting if you have a big JSON field that you can parse as well, and we saw parsing as well. Currently, not being able to reference external data because it's happening at ingestion. So the data available is what we ingest at that moment.
Okay, great, thank you. The next question, are we paying to ingest data before it is filtered, or are we only ingesting the resulting filtered data? Can this be leveraged for cost savings?
Right, so good question. So the data that you filter at ingestion time with this feature that we talked about, that data that is filtered will not be charged for the whole log analytics and Sentinel cost. So only the data that lands into the workspace after the transformation happens, after the filtering happens, that's the data that will be charged for the full Sentinel and log analytics price.
Great, thank you. Next question. Is this aggregation feature provided to us pre-configured, or what do we need to do?
Right. So the aggregation, as we said during the webinar, that cannot be done solely with this feature with ingestion-time transformation. You need something like Logstash, as we did in the demo, to do the aggregation.
Gotcha. Thank you. And the next question we have is, what happens to custom logs that do not conform to the user-defined schema?
Not sure I understand the context.
We can table that one.
Yep.
Okay.
Next question is, recently I came across a sign-in event where the authentication method does not support CA. The sign-in got blocked, but it showed success in the log. Will I be able to change these values upon ingestion?
Yeah, absolutely.
Yeah.
So if it's a field that you have in the sign-in logs table and it is coming into the workspace, you will be able to reshape the data as it is ingested, changing values if you want, adding additional fields for that sign-in logs table, and so on and so forth. Yes.
Great. And another question we have is, actually, What are the recommendations to reduce cost from operating Sentinel?
So I can take that. Definitely start using ingestion-time transformation for filtering. And we really want our customers to use the data they need and to optimize their cost. So either you can use today also AMA to filter data at the collection point. But if you, for any reason, cannot do it there, you can filter out data in Ingestion-Time and really use only the data that you need and pay only for the data that you need. Definitely that can optimize cost, and yeah, I hope that answers the question.
Great, thank you. I think that's all the questions we have for today. So I'd like to thank Eddie and Javier for being our guests today and for an excellent presentation. And thank you to the rest of the team who helped answer questions. At the same time, I would like to remind the listeners that the best way to ensure you don't miss any future webinars or major announcements is to visit our landing page at aka.ms/securitycommunity. And while there, you'll find easy ways to navigate and find the resources and learning content relevant to our security products and their communities. A good start would be browsing our bite-sized product videos, ninja trainings, recordings of past webinars, GitHub communities, and more. We love to hear your feedback on how we can improve these webinars. Please take a minute submitting your webinar feedback at aka.ms/security webinar feedback. Thank you and see you next time. Goodbye.